I'm analyzing a machine learning problem using Scikit-learn's SparseCoder. We're focusing on how changing a specific parameter, transformalpha, affects the results. This parameter controls how sparse, or how many zeros, the resulting data has. We'll look at its impact on sparsity, reconstruction error, and computation time. If I decrease transformalpha, I'll force the model to use fewer components to reconstruct the original signal. This will likely lead to a larger difference between the original and the reconstructed signal. Think of it like trying to rebuild a Lego castle using fewer bricks. The final result won't be as accurate. Intuitively, you might think that fewer non-zero entries means faster computation. However, the dominant factor affecting computation time here is the algorithm itself, not the sparsity level. Changing transformalpha doesn't significantly alter this. I'm using transformalpha as a tuning knob. A smaller value makes the model strongly prefer solutions with many zero entries, increasing sparsity. It's like adding a penalty for each non-zero entry in the solution. By decreasing transformalpha, I'm directly encouraging the algorithm to produce codes with more zeros, resulting in a sparser representation. It's like telling the model, I prefer solutions with lots of zeros. The dictionary remains unchanged when I only adjust transformalpha. Transformalpha only impacts how I transform data using the pre-existing dictionary. I'm not retraining the dictionary itself. This question explores how changing the _transform_alpha parameter in Scikit-learn's _SparseCoder affects the results. _SparseCoder finds a sparse representation of data using a learned dictionary. _transform_alpha controls how sparse the representation is. A smaller alpha means we want a super sparse representation. Think of it like this. Imagine you're summarizing a long story. A small alpha is like trying to tell it using the fewest words possible. By lowering _transform_alpha, I'm making the algorithm prioritize sparsity. That means I force it to use fewer non-zero entries in the sparse codes. I'm pushing it to find the absolute minimum number of important features to represent the data. Because I'm forcing super sparsity by lowering _transform_alpha, I'll likely lose some detail. The reconstructed signal won't match the original as perfectly as before. It's like trying to reconstruct a picture using very few pixels. You'll lose the finer details. It's a trade-off between sparsity and accuracy. While fewer non-zero entries might speed things up a tiny bit, the main computational cost is from the OMP, orthogonal matching pursuit, algorithm. The effect of _transform_alpha on computation time is generally negligible. Don't expect significant speed improvements here. The dictionary is learned during the _fit step, completely separate from the _transform step where _transform_alpha is used. Changing _transform_alpha only changes how the existing dictionary is used to represent the data, not the dictionary itself. Think of it as having a set of building blocks, the dictionary, and _transform_alpha only affects how I choose which blocks to use for each build, representing each data point. I'm changing the transformalpha parameter in the SparseCoder model from 0.1 to 0.01. This is a regularization parameter that controls how sparse the output codes will be. A smaller value like 0.01 pushes the model towards creating codes with lots of zeros. Think of it like this. 0.01 says, make it super sparse. Let's see what happens. This is the result I get after applying the SparseCoder using the new transformalpha value, 0.01. I expect these codes to have even more zero entries compared to the ones generated with transformalpha equals 0.1. Remember, the SparseCoder's job is to represent my data using a combination of dictionary elements, learned in the fit step, and this output represents the weights of that combination. More zeros mean fewer dictionary elements are used to represent each data point. This refers to the entire scikit-learn model I'm using. The model already has a dictionary, learned during the fit step, and now I am just modifying the parameter transformalpha for the next step, transform step. The model structure itself isn't changing. This column refers to my input dataset. This is what the SparseCoder model processes, and it does not change in this experiment. I am focusing on the changes made in the model's transformalpha value. This section focuses on understanding how changing the transform_alpha parameter in scikit-learn's SparseCoder affects the results of sparse coding. I'll examine what happens when you decrease this regularization parameter. Think of it like adjusting a dial. This is the core question. I'm given a sparse coding problem using scikit-learn's SparseCoder with a specific transform_alpha value. I'm asked to analyze how changing transform_alpha will change the output, specifically focusing on sparsity, reconstruction error, and computation time. Let's dive in. This is where I consider a reduced transform_alpha value, going from 0.1 to 0.01. This is crucial as this change directly impacts the sparsity constraint in the model. A smaller alpha means I'm prioritizing sparsity more. This refers to the overall process of finding a sparse representation of the input data using a dictionary learned by the SparseCoder. The SparseCoder algorithm aims to represent signals using a linear combination of dictionary atoms, with as few non-zero coefficients as possible. This is all about finding the most efficient representation of the data. This is the outcome of interest. I'm investigating how the change in transform_alpha modifies the sparsity of the solution, how many non-zero entries in the sparse code, and the accuracy of signal reconstruction. The trade-off is between how sparse the representation is and how accurately it reconstructs the original signal. It's a balancing act. I'm examining how changing the transform_alpha parameter in scikit-learn's SparseCoder affects the results. Specifically, I'll focus on what happens when you decrease transform_alpha from 0.1 to 0.01. This parameter controls how sparse the output of the SparseCoder will be. By decreasing transform_alpha*, I'm essentially telling the algorithm to prioritize sparsity. This means it will produce codes with more zero entries. Think of it like this. A smaller transform_alpha imposes a stricter penalty for having non-zero values, thus forcing more of them to be zero. It's like a chef being told to use fewer ingredients to create a dish. The result will be simpler, but might not be as rich or complex as the original recipe. Because I'm pushing for increased sparsity with a smaller transform_alpha*, I anticipate a trade-off. The reconstruction of the original signal will likely be less accurate. With fewer non-zero entries, it becomes harder to perfectly capture all the nuances of the original signal. The reconstructed version might lose some details, like trying to recreate a detailed painting using only a few simple colors. I don't expect significant changes in the computation time just from adjusting transform_alpha. Although, very sparse codes could marginally decrease computation, the dominant factor controlling computation time is the orthogonal matching pursuit algorithm's (OMP) complexity, which isn't directly affected by transform_alpha. It's like changing the recipe slightly. It might cook a tiny bit faster, but the overall cooking time is dictated by the recipe itself. I'm only changing the transform_alpha parameter during the transform stage. That means, after the dictionary is learned, during the fit stage, only the way the algorithm represents the data changes, the sparse codes, not the dictionary itself. The dictionary remains untouched by this particular parameter change. It's like changing the way you organize the ingredients in your pantry, transform step, but the ingredients themselves, dictionary, stay exactly where they are. This simply means I'm setting the transform_alpha parameter to a value of 0.01. This smaller value compared to the initial 0.1 will strongly encourage more sparse codes, more zeros, in the output of the SparseCoder. I'm using scikit-learn's SparseCoder, a tool that helps find a concise representation of data using a smaller set of dictionary elements. I've already trained it using a specific setting, transform_alpha equals 0.1, and a particular algorithm, orthogonal matching pursuit or OMP. The question explores what happens when I tweak that setting. I'm changing a key parameter called transform_alpha from 0.1 to 0.01. Think of transform_alpha as a dial controlling how simple I want the representation to be. A lower value means I want an even simpler, sparser representation. These are the results, the simpler representations of the data that I get after making the change. It's a set of numbers showing how much of each dictionary element is needed to reconstruct the original data. By decreasing transform_alpha, I'm forcing the model to use fewer dictionary elements to represent the data. This results in sparser codes, meaning many entries in these codes will be 0. Because I'm forcing greater sparsity, the reconstructed data might not perfectly match the original data. The difference between the two is the reconstruction error, and it's likely to be larger now. It's unlikely that computation time will decrease. The core algorithm, OMP, is what dominates computation time, not the magnitude of alpha. While a slightly sparser solution might marginally improve speed, it's not a significant factor. The dictionary, which I learned in the initial training step, remains unchanged. The change in transform_alpha only impacts how I use that dictionary to represent the new data, not the dictionary itself. This is a set of representative elements that the SparseCoder learns from the training data. It's like a set of basic building blocks that I use to reconstruct the data. My input is a dataset of sparse signals. Think of each signal as a picture represented by a few non-zero pixels, the rest being black. My goal is to find a better representation, using fewer bits. This is the core of the problem. I am investigating the effects of a parameter called transform_alpha on the output of the SparseCoder algorithm, focusing on sparsity, reconstruction error, and computation. I expect fewer non-zero entries in the sparse codes because a smaller transform_alpha encourages higher sparsity.